Hard to discompose. Yeah, sorry, we missed. But anyway, you can always check the videos of the previous classes, right? I'm sorry. Okay. So we're recording now. Here you go. So what we did here, I introduced you to a quantitative way of determining the length of a vector, the magnitude of a vector. That's the result of the summation between two other vectors. The summation between the two other vectors. And if you have like C is the summation of A and B, the length of C is related, the square of C, right, is equal to A squared plus B squared minus 2AB cosine of gamma. Just like I have the formula right here. Okay? And then I did the special cases of the law of the cosines, 3 special cases of the law of cosine, gamma equal to 90 degrees, gamma equal to 0 degrees, and gamma equal to 180 degrees. Gamma equal to 90 degrees corresponds to the special case of the Pythagorean theorem. Gamma equal to 0 degrees correspond to two vectors that are anti-parallel to each other. Okay, the difference of magnitudes of the vectors, difference of the magnitudes of the vectors, okay? Of the vectors that are anti-parallel to each other. This is verified by the graphical analysis of the situation of the problem, not the situation, the problem, right? Of the problem. Magnitudes of the vectors, of the magnitudes of the two vectors that are parallel to each other. This is verified, right? To each other, parallel to each other. Okay. And in this case here, which corresponds in this special case, comma, the vectors are perpendicular to each other, and the law of the cosines reduces to the Pythagorean theorem. Right? This is verified. This is verified by the graphical analysis of the problem. And I'm going to do the same here. In this special case, the vectors are parallel to each other. Okay? The vectors are parallel to each other. And the law of the cosine reduced to the difference of the magnitude of the vectors of the two vectors. Okay? Comma. In the other one, in the special case, the vectors are parallel to each other. Here's parallel, anti-parallel, and perpendicular. Okay? And the law of cosines, reduced to the summation of the magnitudes of the two vectors. This is verified by the graphical analysis of the problem, and I want to keep it recorded here, how they are illustrated here. Here you go. Right? You start with the most generic triangle, or let's say the most generic summation of vectors. and then come up with special cases, where the angle gamma becomes 90 degrees. And I should make it green, right? To keep it consistent with the colors that we have here. Yeah, didn't do it. Strange. Well, for some reason, it didn't change the color, but that's okay. Okay, the vector A, which was something like that, now becomes something like that, and the resulting vector C changes as well. Right? Here is the case of the two vectors that was first, not first at a genetic angle gamma, then at a 90 degrees gamma, 90 degrees angle, and now as we decrease the angle until it goes to zero, right? Vectors that are 0-degree angle between each other, and don't forget the angle is measured with respect to the angle here in this case is measured with respect to this angle here, right? The internal angle opposite to the C vector. The magnitude of the resulting vector is one original vector minus the other. And finally, at 180 degrees, right? Here you go. Initially, the vector was like that. Then I put it like that, 90 degrees. Then I put it like that at 0 degrees. Gamma becomes 0 degrees. And then the last one is when gamma is 180 degrees. The resulting vector is the resulting magnitude of the vector is the summation of the magnitude of the other two vectors. Okay, so that was the recording that I missed. Okay. (9:41) now. Let's take attendance. Okay, looks like we will have to cover the other one next time. Components and additional vectors we'll cover next time. We'll cover next time. Okay, and let's go for our attendance here. I have 23 students. Let's see, Audrey Aguilar, are you there, Audrey? Yeah, thank you. Matthew Aguirre Mata.
Good morning, Professor.
Good morning. Next is Darius Blending.
I'm here.
Hello, Darius.
Hi.
You say
Good
something
morning.
there. I hardly could hear you, but I'll give attendance. Okay, Brianna Carrillo. Thank you, Brianna. Jazzy Castellano. Thank you, Jazzy. Gabriel Contreras.
I'm here.
Thank you, Gabriel. Liliana Cortez. Let's see if Liliana is here. Liliana is not in my roster here. Juan Escalera. Are you here, Juan? Doesn't look like he's here. Escalera. Yeah, I don't see Juan Escalera here. Next is Molly. Molly Fitzgerald.
I'm here.
Thank you, Molly. Next is Henry Kim.
I'm here.
Thank you, Henry. Next is Ruth Mandujano. Ruth, I see Ruth here. Hello, Ruth. It looks like she's away from her computer. Next is Noemi Martinez. I think that I saw Noemi here. Oh yeah, thank you, Noemi. Good. Danae Miller.
Here.
Thank you, Danae. Next, Ramon Olivares.
Here, Professor.
Thank you, Ramon. Taylor Thorne.
I'm here.
Thank you. Alexis Pijada. Alexis Pijada. I don't see Alexis here, huh? It's missing lots of meetings. Okay, Stephanie Ramos.
Hi, Professor. I'm here.
Thank you, Stephanie. Next, Jeremiah. Jeremiah Reyes. Thank you, Jeremiah. Sean Rosario. Hello, Sean. Okay, I'm going to put a star here for Sean. Okay, thank you, Sean. Ali Standard.
I'm here, Professor.
Thank you, Ali. Jason Street.
Here.
Thank you, Elena Trujillo. Elena T. Hello, Elena. Okay, Elena's not answering. Let's put here star. Oh. And next is Jason Valadares.
Here.
Thank you.
Here, Professor.
Elena.
Yes.
Okay. Stephen Vathapali.
Here.
Thank you, Larell Williams. I don't see Larell. Yeah, I don't see him. Huh. One more, Nohamian Wandimu. Thank you, Nohamian. Next, Alia Zavala. Thank you. 19. Let's see. Let me give a chance. Opportunity. Ruth, are you there, Ruth?
Ruth is here.
Okay, thank you. One more. Let's see. 20. I have 22 students here. Who was not called? Let's see if I have the right summation here. Yeah, I do have the right. Okay, here you go. That's the problem. Okay, 23. Okay, I'm getting 23, but then there are 22 students. Someone must have left here. I wonder who was that, but that's okay. It is 9:46. Okay, break. 9:46 a.m. to 10:01 a.m. Any questions before I go for the break? Okay, so I see you in 15 minutes. Okay, I'm back here. And now we are going to look into where we stopped, right? Or in the lab. Okay, we were talking about the rules of significant figures. Okay. The rules for significant figure. See, I'm going to put the break right in here. Insert, page break, back to lab 1. Okay. Rules for significant figures. Okay, we have to worry about two two types of different rules for significant figures. Rules for measurements and then we also have rules for results. Okay, before you can have, and let's not forget, before you can have any results and results in a lab, right? In a lab activity, comma, first you must have your raw data or your raw measurements. Okay, so yeah, the rule for significant figures and the rules for measurement, in this course, okay, in this course, I am adopting the most conservative. I'm adopting a conservative technique. In terms of reporting of the measurements. Okay. So how do you do? I prefer this method. Okay, so we report the significant figure of a measurement up to the resolution of a device. Okay, so here you go. Resolution of the ruler, resolution of the device, the smallest or the smallest division in the device. Okay, now resolution of the ruler. Okay, you should know that already, right? 1 millimeter. There are rulers out there that has a resolution of 0.5 millimeter. It's not easy to find those rulers, but they exist. But most rulers have 1 millimeter resolution. Okay, 1 millimeter resolution is 0.1 centimeters, which is, by the way, 0.001 meter, which is our main SI unit. Okay, resolution of the ruler. Okay, so we're adopting this resolution and a measurement, example of a measurement. Okay, so if you're measuring like 15.7 centimeters long object, 15.7 centimeters long object, you stop writing here in this decimal place because that's the resolution of the ruler, right? Which is also 157 millimeters, which, by the way, 0.157 meters. Okay? You stop right here. You do not add, it would be incorrect. Under this rule, it should be incorrect to add another figure past the significant figure 7. Okay? And then let's look at the resolution of the vernier caliper. Okay, the resolution of the vernier caliper that we have there at the college is 0.1 millimeters or 0.01 centimeters or 0.0001 meters. Okay, so now in the case of the vernier caliper, we can add the 0 here because it has a higher resolution than the ruler. Now this 0 is a significant figure. And we can add it here, and we can add it here. For this specific measurement, see, we have, here you go, for the ruler first, right? Example of a measurement like that. Let's organize it better. I'm going to, yep, like that. In the above case, we have 3 significant figures. Okay, 3 significant figures, 1, 2, and 3. See, and all the other measurements that you have here must have the same number of significant figures, even though they are in a different unit. Okay, all all the above measurements. Let's see. No, let's put it in a different way. Measurements displayed under different units, comma, must have the same number of significant figures. It doesn't matter if it's in a different unit. Okay, so here we have 3 significant figures, here we have 3 significant figures, and here we have 3 significant figures. This number here, this 0 here, is not a significant figure because it's to the left of the leftmost significant figure. Okay? And if I'm going to write that in kilometers, the same thing applies. Okay, I can write like 0.000, right? 157. Let's see if we have it. 1, 2, 3. Yeah, we can put this measurement in kilometers as well. Okay, and we're still going to have 3 significant figures because this 0 here to the left of the leftmost significant figure is not. These zeros, right, are not significant figures. Okay, we have 3 significant figures, and I'm gonna write that down here too. The zeros to the left of the leftmost significant figure are not significant. Okay. Measurements displayed under different units must have the same number of significant figures. Okay, and again here, even though I displayed it in kilometers, right? We still have 3 significant digits or 3 significant figures. And resolution of the vernier. We are going to repeat that for the resolution of vernier, right? So here we go. Let me just copy what I wrote there. Okay, here you go. Okay, suppose that exactly 15.70 centimeters, right? Okay, here you go. Okay, here you go, and here you go. In the above case, we have 4 significant figures. The zeros to the left of the leftmost are not significant, but the 0 to the right of the rightmost non-zero significant figure is, okay, for measurements displayed, just like before, measurements displayed under different units must have the same number of significant figures. 4, 4, 4, and 4. Under this rule, let's see. Under this rule, would be incorrect to add another 0 past the last 0 above. Okay? Under this rule, it would be incorrect to add a second 0 past The last zero above. Ok, mais um aqui, significant resolution of the micrometer. Okay, then the resolution of the micrometer is even better than the resolution of this vernier caliper. Okay. Example of a measurement. Now let's see. Let's add. Let's see. My micrometer came up. Hey, wait a minute. There's something wrong here. Yeah, right in here. Okay. Let's see. What about this one? Yeah. So we must have a zero here to the right after the decimal place. Yeah, we're good. And now we have a decimal place there. Here you go. We have here. In the above case, we have 5 significant figures. The zeros to the left of the leftmost significant figure are not significant. But the zero to the right of any, doesn't have to be the rightmost, of any non-zero to the right of any significant figure. You want to put it here, slash digit. Significant figures, significant digits, the same thing. Measurement displayed under different units must have the same number of significant figures. Under this rule, it would be incorrect to also, under this rule, it would be incorrect to add another zero past the last significant, past the rightmost significant digit, because this digit is above the resolution of your instrument. Okay, and we can repeat that as well. Under this rule, here you go. Because this digit is above the resolution of your instrument, and we're going to, under this rule, to be incorrect to add another figure past the significant digit 7. Okay, repeat it here. Yeah. Okay, and I'm going to, like that. Like that. Okay. Example of a measurement. Like that. Okay. So we have all the rules for, and I'm going to bold face it here, rules for measurements. Rules for measurements, rules for results. Did I cover that? I don't think I did, right? Rule for results. So what I have covered so far is just a summary, right? A review of what we did last time. Wednesday 11. Yeah, that's the one. Okay, I did cover, yes, it seems that I did cover. Oh, there is also the scale, right? The case of the scale. Let's go for the scale as well. Yeah, I didn't cover sequence digits for results, definitely. So there is one more resolution of the resolution of the scale. I'm gonna follow the same script that I have here. Resolution of the scale. Okay, scale. 0.0. The scale that we have, there are all sorts of scales out there, okay? But the scale that I have there, we have there at LA Harbor, I like to use this scale here that has this resolution. This resolution in grams turn out to be written as a resolution like that in kilograms, right? One, two, three, four. Let me see if I'm missing any messages from you, right? Nope. Okay, example of a measurement. Let's say 15.70 grams, right? 15.70 grams should be like that. 1, 2, 3, right? We count for kilograms. And that's the preferable unit of measurement because it's the main unit in the SI system. And let me italicize that. Let me italicize that. Let me italicize that. Let me italicize that. Okay. In the above case, we have 4 significant figures. The zeros to the left of the leftmost significant figure are not. Do we have 4? Yeah, are not significant. But the 0 to the right of the rightmost non-zero significant digit is. Measurement displayed under different units must have the same number of significant digits. Okay, also under this rule, it would be incorrect to add another 0 past the rightmost significant digit because this digit is above the resolution of your instrument. Okay. So let me see here. 23. Okay. Resolution of the scale, example of a measurement, blah, blah, blah. Okay. Rules for results. Now that's gonna be that's the new thing that we're gonna talk about. By the way, another way of displaying those significant digits, okay? Here's a numeric fashion. Before we move to rules of results, I'm going to talk about another way of displaying those significant digits, okay? We can also, here you go. We can also display these significant digits in scientific format. Okay. Sometimes it's very convenient instead of numeric. Sometimes it's very convenient to display it in scientific format. Sometimes it is far more convenient to display a measurement in scientific format. And we are going to come across those instances. Okay, sometimes. Let's see, I want to do that for the ruler first. Yeah, ruler. Okay. Consequently, the above measurements, consequently, the above measurements. What is scientific format? You know, scientific format in powers of 10, okay? Consequently, the above measurements can be written as, okay? Instead of 15.7.57, we're going to 15.7, we're going to write it down as 15.57 times power of 10. In this case, the power of 10 is going to be just one power, okay? If we write that in millimeters, we still, notice that I still kept it in the same number of significant figures, 1, 2, 3. This number here, 10, is not a significant digit, okay? Make sense? Okay, and then we do the same for the rest. Here you go. We have to preserve the number of significant digits. But because it's a different unit of measurement, we have to write that down like a power of 10, the next power of 10, that's 10 to the square, okay? So 1.57 times 10 times 100 is going to be 157 millimeters. And if I have 3 significant figures here, I must have 3 significant figures here as well. In the case of the meter, okay, I still write that down in terms with 3 significant digits, but I have to change the power of 10 now. Instead of 10 squared, it's going to be 10 to minus 1. And if I write here in kilometers, okay, if I write that in kilometers, now it's going to be 10 to what? Minus 4. All right? 10 to minus 4. Is it right? Let's see if it's 10 to minus 4. 1, 2, 3, 4. Yeah? 10 to minus 4. And then we repeat the same for the other ones, right? There you go. Same script. This one should be the vernier, okay? Oh, by the way, and here we can also write the resolution of the, I didn't do that, right? Resolution, let's put the resolution. Resolution. Okay. Now here we don't have, okay, we can write 1 times 10 to the 10th times 10, but this 10 is going to be raised to the 0 power, right? To the 0 power, which is resulting 1. And the resolution itself has just 1 significant digit. And then we repeat for the others. Okay, minus 1. Minus 2. Minus 3, right? Here should be minus 3. Resolution, measurement. 2 different ways of writing our measurement. Resolution, measurement is just a single measurement, right? And I'm gonna do the same for the rest. Resolution of a vernier. Like that, here you go. Copy. and paste. Already did that. Yeah. Resolution. Right? Measurement. But now my measurement is gonna have an additional 0 here, an additional 0 here, an additional 0 here, an additional 0 here. All of them have 4 significant digits. But what about this one here? Let's see. Why do I have that? Oh, okay. Okay, I have to fix this one here. I have to fix this one here, right? That's going to be -1 because it's the vernier caliper. That's going to be -2. That's going to be -4. Okay, and then we can repeat that for the micrometer. Example of measurement, resolution of this. Let's see, micrometer. Example of a measurement. Okay. Okay, we can also display this significant digit in scientific format. Here is going to be 10 to -2 millimeters, 10 to -3 centimeters, 10 to -5 meters. And then we add a significant digit. Okay, we add a significant digit. We add a significant digit. We add a significant digit. We have 5 significant digits, right? Yeah, 5 significant digits. Do I have to, let's see. Yeah, that's good. 10 to square, good. 10 to -1, good. There. And then we repeat. We can also, we can also display this condition in scientific format in powers of 10 instead of numeric, right? We can even come up with a table, right? We might want to do that on your own. And it's a 10 to -2 grams, 10 to -4, right? 1, 2, 3, 4. Now it's 10 to -5 kilograms. -5 kilograms. Ideally would be to put something like that in a table format so you can refer to it more easily. Okay, here you go. And 1.570, 1.570. Okay, kilogram, 1.570 grams. $1.570 kilograms. And then we gotta change here to -2. Yeah, right? 1, 2. Oh, wait a minute. This one here. Did I make a mistake here? Doesn't look like, right? Yeah. Okay. So a measurement and results can be written either in a numeric format or scientific format. When to use the scientific format? When to use the scientific format? Okay. I suggest, okay, you must use the scientific format in every situation where you cannot display two situations, two different one to scientific format, two situations. One, you must use the scientific format in every situation where you cannot display the correct number of significant digits in numeric format. Okay? I'm going to give you an example. Let's see if it's a fortunate example or not. Suppose this one right here. Okay? Suppose that you want, for instance, cannot display the correct announcement in numeric format. For instance, let us say you have to, example, display the following measurement in microns with the right number of significant digits. And here I'm going to show you, this is an example where you have to use the scientific format. This one here. Display the measurement. Okay. Not this one. I got the wrong one. Let's see. This one here. This one that I want. Example, display the measurement in microns. Okay? With the right number of significant digits. You must have, in this case, you must have 5 significant digits, right? So the right way of writing that down, if you were to write that down in not in millimeters, but in microns, look what's happened. Look what happened. You know, to display that in microns, you have to multiply this measurement by 1,000. Okay? Like that. It's not millimeters, it is microns. And I gotta change the first M to the Greek letter mu. Okay? See, we have 5 significant digits here. But here, if you were to write it in terms of the microns, you're in numeric format, you are supposed to add a 0 in there. But the 0 is not a significant digit. Okay? It's not a significant digit. This problem can be resolved by rewriting this measurement in scientific format. What do? We put here 1.57, right? 0.3 eliminates the 0 that's not significant and multiply by the power of 10. In this case, the power of 10 would be 1, 2, 3, 4, 5 to the 5, not to the 4s. Okay? That's how we resolve this type of problems with significant digits. If we have 5 significant digits here, we still have 5 here, right? That's one situation. Another situation that I recommend, it's not a requirement, but is is highly recommendable. It's recommendable. Use scientific format for numeric values below 0.001 and above 1,000. Okay, and above 1,000. When we start adding zeros here to this fractional value, it becomes harder and harder to read the number. So it's recommendable that you write the numbers that are less than 1,000, right, and more than 1,000 in significant digits. Okay, let me give you an example. Display the measurement 0.0005. Okay, let's say that's going to be what, meters. Yeah, that's good. And scientific format. So let's say that you got your micrometer and you measured 0.5 millimeter for a given measurement that you have, just one significant digit, right? So that ends up being written, it's going to end up being written as, 5 times 10. Let's see, 1, 2, 3, 4. Yeah, -4. -4. Okay. It becomes difficult to track when you have so many zeros here, right? That's why we usually use scientific format in this way. Okay, what time is that? 10:41. Let's go another 20 minutes. And now we're gonna go for rules for result. Let's get I gotta get my spreadsheet, right? Here you go. Okay, last time we plotted all those graphs, right? And okay, and here are my results. All those results are less than 1,000, right? So it's okay to display them in numeric format. Okay. Here you don't need to worry about significant digits because that's taken from the literature. And now here you go. Oh, here you go. Here's our results, right? How to display a result. Well, in order to display the result with the proper number of significant digits, first you have to know how you got that result. Okay. In the case of lab 1, right? In the case of lab 1, comma, the raw data are the diameters of the spheres. Okay. And are the diameter of the sphere and their respective masses, right? their respective masses. Did I display the mass with the proper, here you go, here are the mass. All the way down to the 5th decimal place, right? Because it's being displayed in kilogram. Let's see if I sample. I believe I used this one here, right? Let's see. Maybe it was this one that I was using before. Let's take a look. Well, yeah, it looks like I was using the other one. Yeah, okay. Okay, so here you go. Before you can have any results in a lab activity, first you must have your raw data or your raw measurement. In the case of lab 1, the raw data are the diameter of the sphere and their respective masses. Next, you must know the mathematical conversion of the data into your result, okay? And again, in the case of lab 1, next you must know, in the case of lab 1, we want to transform the diameter into a volume, right? Into a volume. The relation and their relation is equal. I wrote it down before, right? First, let's write down in terms of volume. Here you go. Volume is 4/3 of pi. Oh, here. No, here. Yeah. I bought a lousy here. Pi r cubed. That's the formula for the volume, right? And I'm writing that down in terms of the radius. And then I have to write that down in terms of the diameter. Remember, the data, the raw data is not the radius. The raw data is the diameter. It's far more difficult to measure a radius than to measure a diameter. Okay? It's very difficult to estimate the center of the sphere when we make that measurement. So that's what's going to be my raw data. Here is going to be 8 here. The D is going to be cubed as well. And we can display the final result as being 1/6 of the cube. Okay? Right? Like that. So you have to have the formula. Here's the formula. In this case here, this volume is dependent only on the diameter. Okay? The volume, note that the volume is dependent only on the diameter. Consequently, the number of significant digits to display will be the number of significant digits of the diameter. Okay? So you have to count the number of significant digits. So here you go. Table, right? Let's put now is a good idea to make a table. Insert table. Let's see, 1, 2, 3, and then 1, 2, 3. Okay, so here you go. So here measurement number diameter. That's how I'm going to do that. I'm going to do like that. You know, even for come up with a table, it takes some thinking, right? Measurement number 1. Well, let's see. We have just one measurement, and here is going to be my diameters. Merge cell. Okay, I'm going to write down D and meters. I'm going to center justify, and here is going to be my volume. Okay, merge cell, and I'm going to center justify as well. Here you go. Volume, and the volume must be displayed in cubic meters, right? You're going to have measurements for the ruler. You're going to have measurements for the vernier caliper, and you're going to have measurements for the micrometer. Okay? By the same token, you're going to have measurements for the volume. Not measurement for the volume, results for the volume. Okay, here you go. And I'm going to use exactly the values that I have been working with in the examples above. Okay. So here you go. Let's get my ruler measurements. Vernier caliper. You go everything in meters. That's the ruler. Okay, ruler. Once I have this measurement, right, I know ruler, vernier caliper, let's get the micrometer now. That's the micrometer. And the other one, right, would be the vernier caliper. 3, 4, 5 significant digits. See that? 3, 4, 5 decimal places, right? And now we go ahead and just do the math. 1/6 pi d cubed, right? 1/6 pi d cubed, and then you display in the decimal places. Let's do that. 0.157, 0.157. I'm going to calculate the volume. The volume is 1/6 times pi times this to the cube. And look what I get. 00203, right? 00203. That's the volume I'm getting. 0.00203 cubic meters. And then you do the same for the vernier caliper. 3 decimal place, 3 significant figures, 3 significant figures. The number of significant figures is not necessarily the same as the number of decimal places, right? Here we have 3 significant figures, 3 decimal places, coincidentally. This is just a coincidence. But here we have 3 significant figures, but 5 decimal places. Okay? Next, we are going to have 4 significant figures and 4 decimal places. Then we have to have 4 significant figures and how many? 6 decimal places. It's different. Here, Okay, I'm gonna do the math for the micrometer. 703. 703. See, it's gonna do the math for me automatically. Okay, so I have to have 5 significant digits, right? 1, 2, 3, 4, 5. I have to cut down on 2 numbers here. Okay, let's go to format cell number. Let's see. 3. How many decimal places I'm supposed to have? 1, 2, 3, 4, 5, 7 decimal places. Let's see if that's what it is. Yeah. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. 20274. 00202274. That's the right way of displaying the measurements that I used above. Okay. Note that the number of significant figures are not necessarily equal to the number of decimal places. Okay? Not necessarily are not necessarily equal to the number of decimal places. Okay? In the case for the measurements, in the case for the diameter measurement, it is a coincidence that the number of significant figures ended up being equal to the number of decimal places, right? But not for the case of the volume, but not for the case of the volume, right? 3, 4, and 5 sig figs for the ruler, vernier caliper, and micrometer respectively. And 5, 6, and 7 decimal places for the ruler, vernier caliper, and micrometer respectively, right? Okay, so that's the rule for, this rule, by the way, is applicable only to multiplication and division, okay? For addition and subtraction, the rule is different. The rule is different. And we're going to get there. Okay? If the formula involves more than one measurement, okay? Note that in the above, note that in the above result, the formula involves a single measurement, the diameter. However, if the formula involves more than one measurement, then you keep more than one measurement. For instance, the sides of a of a rectangle, the size of a rectangle, right? Then notice that in the above result, the formula involves a single measurement. However, if the formula involves more than one measurement, I'm not okay. Then you use, right, the least number of significant figures of the two, right? Example. Let a rectangle have the following measurements. Side 1 equal to 10.3 millimeters, right? And side 2, 8.5 millimeters, okay? Side 1 and side 2, like that. How many significant figures you want to calculate the area of? You want to calculate the area of this rectangle, right? How many significant figures should the area have? Okay. Solution. Can you picture that? Side 1 has 3 sig figs, right? Side 2, I'm not asking you to calculate the area. I'm just asking you how many significant figures the area is going to have, must be displayed with. Side 2 has 2 sig figs, right? Consequently, the area must be displayed with 2 significant digits. Okay? What time is that? 11:01. We need a break, right? Let's see how you're doing there. And so now you have enough to work on the number of significant digits. Now you have enough to work with the proper number of significant digits, right? Significant digits. Display, display the significant digit. You go. This one here. Yeah. I don't want this one. I want this one here. Okay. Here for this table, I already have everything in the right number of significant digits, right? 2 significant digits here, 2 significant digits here, 3 significant digits here, 3 significant digits here. E to minus 6 here in Excel means 10 to the minus 6, okay? 4 here, we have 4 here. For the mass, we must have 5 decimal places. In certain cases, 5 decimal places will result in 3 significant digits, and in other cases, 5 decimal places will result in 4 significant digits, okay? So you gotta do that for your spreadsheet, for your specific spreadsheet, right? And you're gonna plot the graphs, right? Hopefully you already did that. Make sure you display the axis in the proper way. You don't need to display the axis with significant digits, okay? There's no need to do that. Just display the axis in the simplest possible way so it's not difficult to read. Have you thought about keep on reading those numbers? It's all those zeros, right? It makes you crazy, right? What about those numbers here? Look at how many decimal places I put it here. That's not good practice. Okay? And then you get the regression equation, get the slope of the regression equation, and you log, let's see here. Okay, and you log, that's for the micrometer, you log right in here, 7888, 7588. This one must be for the vernier caliper, see that? Vernier caliper. So 7866, you log in the last table to get the percentage differences between what you got from your experiment, your experimental slope, right? And what is displayed out there in the literature, okay? 1104. Did you get the idea? So what you should do, plot 3 graphs, right? M versus volume. Yeah, fill up the cells with the proper units. Let's see, plot the graph. Oh no, wait a minute. Plot the 3 graphs. Okay, write the slopes of the graphs in their respective cells of the last table, like that. In the respective cells of the last table, fill up the cells with the proper units. 4, adjust the measurements and the results with the proper number of significant digits. Okay? That's what you should be able to do as of now. And 11:05, let's take another break. 11:05 a.m. to 11:20 a.m. Any questions? Okay, save that. If there are no questions, let's go ahead and take a break. I see you in 15 minutes. And by the way, don't forget to remind me to turn on the recording next time, right? So I'm gonna pause the recording, and next time, don't forget to remind me. Primeiro pager, depois eles o walkie-talkie. Vamos ver.
Aí tinha O pior é que explodiu até quem tinha que não era do Hezbollah.
Que não era do Hezbollah, exatamente. Feriu quem era.
Uhum. O cara estava na feira, não sei se ele tinha um, e explodiu.
Okay, I'm back here. Okay, and so let's see how you're doing there. Excel. Okay, so let's go 3 graphs, right? I want to see how you're doing there. So Audrey, did you manage to plot all the 3 graphs? Yes, I'm not. Let's see. This Audrey, yeah. Okay, you're still working. Okay, let me write that down here. Still working. Now, Matthew, did you plot all the 3 graphs?
I have them plotted, but I'm almost done. I'm just doing like the finishing touches.
Okay. Okay, working. So I'm gonna say that you're working on that. Next is Darius. Did you manage to finish the three graphs, Darius?
Yes, I believe
Yes.
the ones from last week.
Oh, remember it's three graphs, right? The ones from last week. That's right. You gotta plot three
Yes,
graphs. You did? Okay. One for the ruler, the other for the vernier caliper, the other for the micrometer, right? And
correct.
okay, okay, good. So Brianna, did you manage to finish all the three graphs? Working on them. Okay. How many graphs have you done so far? Two. Okay, so one more to go. That's good. Thank you. I'm gonna put here two. Just put working. And next, Jazzy Castellano, working on them. How many graphs have you done so far? One. Okay. We have two more to go. Can't block one off. Okay. Interesting. Okay, Gabriel Contreras, have you finished your graphs, Gabriel?
I'm working on it.
How many have you done so far?
Like one.
One. Okay. So Liliana, okay, Liliana, you're not here last time, right? And you are group number 2. Is Liliana here? No, sorry. Liliana is not here. Oh, mixing up. Here you go. Juan is not here, right? Molly, did you finish all the three graphs?
I have.
I have. Okay, good. Yes, all the three graphs. And Harry, did you finish all the three graphs, Henry?
Oh, yes, I have.
You have. Okay. And Ruth, have you finished all the three graphs? Like Ruth is no longer here. Okay, so let's see. Not here. Noemi? Noemi left too. Huh? Okay. Are you there, Noemi? I don't see her name here. Okay, so what I'm gonna do here? I'm gonna put not here. All right. Then I decide what to do about those two here. Danae?
Yes, I finished them.
Three, right?
Yes, I finished them.
Okay, good. And did you also do the units?
Not sure.
I'm not sure. Okay. First of all, well, after the graph, right? So you have the log slope. That's what you have to do, right? And then you're gonna get the percentage difference, okay?
Got it.
And then you do the units, right? You're gonna do then the sig figs. Then what else we have to do here? Okay, sig figs. And those are the slopes. Those are the values of the slope. The units go in those cells here. There are the units. That's where the units go. Oops. Let's do that again. Here, units. That's units already in there, right? And units. Okay. Then work on the sig figs. Everything that's in red do not require sig figs, okay? No sig figs here, no sig figs here. What else? Oh, the slopes. Okay, yeah, you gotta log the slopes, right? After plotting the graph, you log the slopes, and then check the percentage difference. Usually in this experiment, you get, if you get less than 15%, you're good. Okay, you're in good shape. If you get more than 15%, either you did something wrong or the data that I provided you is no good. Okay, it's no good. That's not it's no good. That because it has some problems there. Okay. Let's see what else. Oh, the last but not least, right? The CL. The CL. Let's see here. CL. So let's go to the next. Ramon, did you finish all the three graphs?
Yes, I did.
Okay. What about the rest? Did you do the rest too? Log
No,
this.
I'm working on that right now.
You're gonna do that now? Okay. Now let's see. Next is Taylor. Did you finish all the graphs, Taylor?
We did the graphs, yeah.
Oh, okay. What about, did you log the slope?
We're working on it.
Okay. Units, right? Sig, and CL.
We did the units.
Oh, you did the units? That's good. Okay, so now I'm putting here yes for the units. But don't forget to log the slope and check the percentage difference. Alexis is here. I don't see Alexis here. Okay, Stephanie. Stephanie Ramos. Okay, still working on them. Still working on the graphs, right? 11:30. Okay, Jeremiah. We got the graphs to work. Okay, that's good. Did you log in the slopes as well there in the left table? Jeremiah? Okay, so let's see, Matthew finished the, oh, okay, so let me just repeat here. Once you finish the graphs, when you plot the graph, right, don't forget to put the regression equation, the R square. You're going to need those two, right? And after doing those two, you go ahead and log the slope in the last table, right in here. The slope for the ruler, the slope for the vernier caliper, the slope for the micrometer. And look at the percentage difference. The percentage difference here are being calculated automatically for you. Okay? And this should be, less than 15%. If it's not less than 15%, let me know. And we try to troubleshoot to see what's going on. Okay? Is that clear now? And don't forget also the units, right? Not just log the slope, but type there the units there. Sean, are you there? Did you finish the graphs? Yeah, okay, good. Did you log the slopes in that last table? Not yet. What about the units? Did you manage to do the units, to fill up the units as well? Not yet, okay. So next, Ali, standard. Graphs, slope, and units. Did you manage to do that, Ali? Working on them, okay. So priority, don't forget the priority are the graphs, right? And the JSON. Did you?
I'm working on them.
You're working on them?
Yes.
Okay, it looks like I just noticed that there is a student that doesn't have a group, right? Nuhamin, are you there? Let's see. No, he left. Huh. What a shame. Nuhamin Mwandimu.
Hey, Professor, real quick.
Yeah.
it seems that I lost the information for the last column for my like chart. Like to the right of the micrometer volume. Could I see that one more time, just so I can make sure I have it right?
Show me which column. This one here for the micrometer.
Yeah, where it says scale.
For the volume.
Oh,
Okay. So
yeah, I was missing.
you can do the following. You can download the spreadsheet again from the group folder. Okay, that's one possibility.
Oh,
Okay.
I see.
Or you can type the formula. You can type this formula here in the. Oh, there's even easier to do. You can highlight instead of typing the formula. You can highlight this column right here. Do you still have the values here for this column?
Yes, I was just missing the last column where it says scale. Like I didn't have the values.
You're just missing this one here?
No, where it says scale.
The scale. Okay, the scale.
Yeah, I was
okay, the scale. You have to download the table again. Download the table again. That's in the group folder, and just copy and paste it.
Oh, okay. Thank
raw
you.
data. Okay.
Okay, thank you. I'll do that. Thank you.
Your group number. Let's see. Your group. Which group number are you?
Are you asking me?
Yeah, Jason, right?
Oh, sorry. Yeah, I'm in group 5.
5. Okay, so check there the spreadsheet of group 5. Okay, and okay, so if you don't have the math in there, you won't be able to plot any graphs, right? Okay, let's go. Let's go to Elena. Elena, are you there? How do we get the equation? The ones on. Okay, still working on them. Okay, how do we get the equation? Jeremiah is asking here, right? The equation, the one on our graph, look different from yours. Are you talking about the equation for the volume, Jeremiah? Yes, okay. Okay, so here you go. The equation here for the volume, I type it as being 4/3 pi, d/2 squared. But you could also type in a different way too, okay? You could type it like a 1/6, right? Pi times the diameter. The diameter in this case for the ruler would be this one, okay? That's another way. How do you type your equation there, Jeremiah? Are you there, Jeremiah? Of the graph, the equations of the graph. Oh, you're talking about the equation of the graph. Okay, the regression equation, right? You're talking about the regression equation, right? Not the equation in the cell. Okay, good. Yes, it's going to be different. Whatever I have here is going to be different from yours because those data are different from yours, okay? So every group is working with different data sets. So if I'm getting 7588 here X and you get something else, that's common, that's normal. There's no problem. Okay? What you have to pay attention, how did you reach it? You mean how did I display it? Okay, so let's do that again, right? I'm going to erase. You go, you're asking me how I got the equation here, right? Okay, so what you gotta do? Click one of the data points. Everything is highlighted. See that? Right? Here you go. Click on the data points. And that procedure is spelled out in the syllabus as well, right? So here you go. Go back to one of the data points, right click, and then you highlight add trend line. Add trend line. Okay, this pane is going to show up in the right side. Linear should be clicked, should be selected. Then you display equation chart, display R square value on chart. Okay, and here you go. After I did all of that, the equation went back to its position in the graph, on the graph. How do we figure out the N and M value? Okay, here you go. Okay, so it's just a way. Who is that? Molly, right? Okay, Molly, so the N, what's the N? N is the number of data points here in the graph. You have 1, 2, 3, 4, 5, 6. Okay, that's our n is. Oh, yeah, and it's written here, number of data points n. Okay? What's m? M is just the regression equation. Okay, the regression equation, what I call y is in reality my equation for m. Okay, here you go. Oh, okay, it's not working for some reason. Let's see here. Yeah, now it worked. Okay. What is y is in reality the value for the mass. What is x is in reality, the volume, right? So the m is going to be just this equation that you obtained from the regression equation, okay? So you go ahead and type, the equation right here. In my case, it should be, this one is the micrometer I want for the ruler, right? Let's see here. I want for the ruler. Yeah, that's the ruler. So we copy this equation right in here and we paste here, okay? And we replace the x with the v. That's how you do it. Next, let's see. Jason Valadares. Did you?
Yeah, I got the graphs done.
All the three, right? Okay, did
Yeah.
you log the slope as well, Jason?
I just finished logging the slopes, and now I'm doing what is it? The instrument.
Okay. What's the percentage difference you're getting there for the slopes, for the three slopes?
See, that's the question I have. When I click on it, I just see 0 period E plus 0, 0. I don't really see a percentage there.
Okay,
I'm
so
not sure what's going on.
yeah, you have, most likely you have to change the format here, okay?
Okay.
Highlight all the three cells, right click, okay, format cell. In my case, the number is already selected, see that? Go in the number tab, right? You have all those tabs here. And then most likely you have the scientific here selected in yours, most likely. So you
Yeah, I
select
do.
the number. Did you do that?
Yeah. Okay.
What do you have now?
For the ruler, I have 0. For the vernier caliper, I have 3, and the micrometer, I have 4.
Okay, so let's see. Let me write that down. That's Jason, right? 0 what? 0?
I have 0, 3, and 4.
But it should be 0 point something for the ruler. So you have to, here you go. You have to increase the number of decimal places. Okay, so here you go. Highlight, right click, format, right? Number, and go, put 2 decimal places there so you don't get a 0.
Okay, I got it now.
Okay, what do you get now?
So for the ruler, 0.00.
Oh, it's just 0.00. That's strange. Okay.
And then the caliper, I have 3.01.
3.01.
And the micrometer, I have 4.44.
4.44. So let's see. You are group number 5. Let me check why you're getting 0 for the ruler. Seems to, too much of a coincidence. Here you go. Group number 5, right? 4. Number 5. Okay. All I need to do is to plot mass and volume for the ruler. Let's see. And add trend line, display. Did you get 7717 for the slope? Jason?
Yeah, I got 7717.5.
Yeah, okay, now I'm going to put it here. Oops, 7717.5. 17.5. Something divided by 0. Oh yeah, that's because I didn't put the. Did you log the density here in the first table?
Yeah, 7,900.
7,900, okay. Let's see what am I getting here. Yeah, you said it. See, I'm getting 2 here. I'm not getting 0 like you mentioned, right? Number. Yeah, I'm getting 2.31%, 2.31%. See that?
Okay. What's the equation you have up there? Maybe it's a little bit different.
Yeah, maybe yeah. The equation is like that. ABS, do you see
Yeah.
here?
Mhm.
ABS, open parenthesis, K, oh, see? I just erased the equation, but now it's back. K51 minus K16,
Okay.
$K, $16, close
Okay.
parenthesis.
Does it need to have those dollar signs or?
I don't have to, but it's better. Put that, it's better in case you need it later on. $K, $16, close parenthesis, times 100, divide by $K, $16.
I think that's because I have like L49 times
L,
100.
L51.
Okay.
Wait a minute, I'm sorry. It's L50 actually. Let's see. No, it's K50. Sorry, here. K51, $K, $16, right?
Okay.
Is this column here?
Okay, I got 2.31 now.
Okay, good. Maybe it was the equation that was raised there. What about the other 2? Let's make sure that you're getting what I get. Okay, I didn't log. Okay, let's assume it's right. But at least we fixed this one. Okay, let me go to the next student. Stephen, okay, now you got 2.31, right? 2.31. Stephen,
I'm still working on it.
you're working, okay. So let me see. There is a student who finished a graphs and units, working on filling the table 3 and 4. Okay, that's Alia. Okay, finished. Okay, and let's see. Laurel is not here. Nuhamin, are you there? Nuhamin Mondimu? Yeah, I don't see Nuhamin here. Okay. Let's put like a red. Not here. Okay, and Alia. Okay, Alia finished. And finish the graphs. Working on filling out tables 3 and 4. Everybody has a group, right? If you don't have a group, let me know. So, 11:47 now. So, Audrey, did you finish the graph? Audrey? Hello, Audrey. Don't hear from you. Okay, let's see. Go to the next one here. Next is Brianna. Did you finish the graph, Brianna? She working on the last graph. Okay, good. So let's see. Next one is Jazzy. Did you finish the graph, Jazzy? Work on the last one. Okay. Next here is Gabrielle.
Not yet.
Not yet. Okay. Not trying to put pressure on you. Let's see. Let's see if it Ruth. Are you there, Ruth? No, Ruth's not here. Noemi, let's see. Noemi is not here. Stephanie? Yeah, okay, you finished. That's good. And did you log the slopes, Stephanie? Not yet? Okay, log the slopes there, and then I'll get back to you later on. Ali, did you finish the graphs, Ali? Ali standard. Where is she? Yeah, I don't see Ali here. Oh my goodness. So one more. Not here. 1, 2, 3, 4. 19. Yeah, good. Ali. Next is Jason. You finish the graph, Jason?
No, not
Jason
yet.
straight.
I'm finishing touches.
You're finishing. Okay. Elena Trujillo, did you finish the graphs? The 3 graphs? Not yet. Okay. Do you need any help? Are you having any problems plotting the graphs there, Elena? Any, maybe you need some help there. Okay, so let's move on to Stephen. Stephen.
What was it?
Stephen Vashapali.
Yeah.
Are you Stephen? Okay. Okay, good. Did you finish the graph, the 3 graphs?
No, yeah, I'm still working on it.
Okay. Good. Okay, so I'm gonna give you a little bit more of time. Let's see. How do we get the CL min and max? Yeah, okay. So you gotta use that table, Henry. Get the table. It's did you download the table, the CL? Let's take a look there at the Google Drive. At the Google Drive, no, the table in Canvas. The first thing you have to do is to download the table. Here you go, the confidence level table here. Do you have it? Here you go. Yeah, download this table, first step. Do you have this table, Henry?
Oh, yes, I do.
Huh?
Yeah.
Yeah, you do. Okay, good. So let's see your group number. I'm gonna help you with this table. Henry, right? Henry Kim. Your group number 2, right?
Mhm.
Yeah. Okay, so let me get your spreadsheet here. Group number 2. I'm gonna do just for one graph, okay, and then you can do for the rest. You plot ruler, right? Mass and volume for the ruler. Insert chart. Okay, and now you gotta fit a regression equation there. Attend line, linear, display equation on chart, display R square value on chart. Okay? Kind of small, right? You go, difficult to see it. So you're going to need R square. Okay? Get this value of R square, 0.9798. You put right here, 0.9798, right? You put the number of data points here. It's going to be 6. I'm going to put, here we go, number, numeric format, 1, 2, 3, 4. Okay. And now you're going to find the CL, the lower boundary and the upper boundary of the CL. So here you go. Let me download this guy. Okay. Okay, I downloaded. Open the table. Right? So what you're going to do, because you have 6 data points, you have to look at this row here, row for n equal to 6, okay? That's the first step. Okay? And then you look at the R square. Your R square was 9798, 0.9798. So look here in this row where 9798 fits into it. You can see that 9798, 0.9798 is between those two values of R square, right? Okay. 9798 is greater than this one here, and is less than this one here, okay? So what are you going to report? You're going to report those two values here. The minimum for CL is the lower bound of CL, 1 minus 10 to minus 3, okay? And the maximum is the upper bound of CL, 1 minus 10 to minus 4. Okay, so I'm gonna type there 1 minus 10 to minus 3. Here you go. And the way you do it is like that. Equal 1 minus 10 to minus 3. Okay? And then let me just turn into a numeric format, very important. Put like 5 decimal places, right? And the other one here is going to be, again, equal 1 minus 10 to minus 4. So my actual CL, my actual confidence level, is going to be a number between those two values. That's what it means, okay? Is that clear?
Yes, got it. Thank you.
Okay, so you gotta consult that table that I provided you. What time is that? 11:56. Right, so we're running out of time here. So you have everything that you need now to finish this table. Okay? So I want you to finish this table, go home, right? Finish this table as a group. Okay, finish. And then you upload. Go finish. Please finish the spreadsheet for lab 1, lab number 1, okay? And upload it to your group folder. It is due, just the spreadsheet, Later on, we worry about the hard copy, right? Do that just do that only for the spreadsheet. Later on, we will worry about the hard copy, right? Okay, the spreadsheet is due. Next, before the next lab meeting, which is, okay, 9/25, right? Okay. Yeah, right in here. Let me highlight it here, boldface it. Professor, will this video recording be on modulus after this? Oh yeah, they are all there. Okay, let me show you. This one I will upload it as soon as I can. Okay. Sometimes I get behind because Zoom takes some time to to prepare the video for me. But here, if you click on go to home, right? Home, links to 2024 videos. As of now, the last video that I uploaded was the video of the day before yesterday. So this one, hopefully I'll get it today. Maybe you have access the latest tomorrow. I'll be able to review the steps again to make sure. Okay. Yeah, so I will upload, and if so, for some reason you cannot see the video, right, of today's classes, check the video of last semester. Whatever I did last semester is very similar. It's not exactly the same, but it's very similar to what I did today. Okay. Let's see, lecture to bed on the motion, maybe on the 18th, on the motion, but maybe on the 13th, you know, you might want to look at the 13th, the video of 13th last year. But I'll get today's video as soon as I can. Okay, 12 noon, right? And that's all we'll have for today. If you don't have any questions, I will see you next Monday. Okay? And don't forget to work on the homework, right? Don't forget to work on the homework. Yeah, don't forget to work. Don't forget to work on the homework. The deadline for the homework is coming closer and closer in while plus. Okay. So I see you on Monday. Bye-bye.
Thank you.
Welcome.
Thank you, Professor.
Welcome.
Professor, can I ask a question?
Sure.
So my CL minimum and max, or my R squared, is 0.9927. So would the maximum be the 10 to the negative 3?
Let's see. 6 is 6, right? Right in here. 9, you said 9927? Is that what you said?
Yeah, 9927.
Okay, 9927 is, let's see, 9927 is between those two numbers here, right? Do you see that? 9927 is less than this one, is more than this one. So is 1 minus 10, the CL minimum, CL min is 1 minus 10 to minus 4. CL max is 1 minus 10 to minus 5. Okay?
Gotcha. Okay, thank you so much.
Those two. And let me see, Jeremiah, right? Jeremiah said R squared 999. Okay, Jeremiah, so your 999 is between those two values, right? Are you there, Jeremiah? Okay, so your CL will be 1 minus 10 to minus 6 and 1 minus 10 to minus 7. And don't forget to put that equal sign, right? That equal sign to calculate properly. Okay. So this thing here is, let's erase it. Clear. Wait, equal sign. Yeah, let me type that for you. It's like that. Here, min, right, is equal. When you type 1 minus 10 to minus 6, right? 1 minus 10 to minus 6, right? That's how you type it. You gotta put this equal sign here, otherwise Excel is gonna treat it as though this thing is a text, okay? And you do the same for the other one. Equal 1 minus 10 to minus 7, right? Yes, The significant, you display the significant figures only here. Everywhere else, you do not need to worry, okay? Only here in this main table. There's no other sig figs for you to display elsewhere. And let me format cell 6, 7. Let's see now. Yeah, good. Okay. Anything else? Okay. You too. Have a nice weekend.
Professor, I actually have one more question.
Yeah.
So regarding the graphs for the first table, with the first table, when it comes to me doing the graphs for it, because you said do it for ruler volume and scale mass, correct?
Yeah, you do for the ruler, right? You highlight the volume of the ruler, and then you highlight the scale, the mass, right? That's how you do it. And then, yeah.
Okay, I think I did it wrong. So I was gonna ask you how you got your graph to look the way you did, but I think it's because I did it. Actually no, I don't. What key are you pressing to highlight those two columns specifically again? Because I forget.
Yeah, first highlight the one of the columns, right? And next you press do you have a PC or a Mac?
I'm on PC.
Okay, so you press the Control key,
Oh, it's
hold the
Control.
Control key, and then you highlight the mass. And then you get both highlighted simultaneously.
I see. I was pressing Shift, my bad.
Yeah, okay, it's Control.
I
Yeah.
forgot that. Okay. Okay, I think that was it. I just forgot which key it was. Thank you, Professor.
Okay, welcome.
Right, have a good one.
You too. Anybody else?
Hi, Professor. So do you have to have a computer in order to get the graph? Because I have an iPad, but because I can't do the highlighting for the ruler and the scale.
Let's see. So you have an iPad, right?
Yeah.
iPad has a command key there?
It does not.
It does not have a command key. I do
No.
not know how to do that for the iPad, okay? What maybe you can try to do the following, since you do not have the command key. You don't have access to a computer either, right?
I can borrow from like my sister, but she's gonna be here later. But
okay, if you
at the
can,
moment,
let me show you a little trick here, okay? So
Okay.
since you do not have the command nor the control key, do the following: highlight all the three all the way
Okay.
up to the scale.
Okay.
Okay, did you do that? And now insert. Now you're gonna get all the three charts plotted in a single one. Okay, see that? There's
So
something.
go to. You said go to insert.
Let me see. Wait a minute. Something wrong here. He plotted. No, it's not gonna work.
No.
What a shame. Yeah, it didn't work. No, yeah, you have to figure out how to do that in your iPad, okay? This one you can do it easily, okay? Because they are next to each other, okay? For the micrometer. The problem is the rest. Let me see if there's another way. You have to figure out how to do that on iPad, or you have to get access to a computer that has the keystrokes in there. Let me see if there is another way of doing that. Insert. There might be another way of doing that. Let's see. Here you go. I'm doing with the micrometer, right? Now. Oh, yes. See that? Hopefully you'll be able to see that. Okay? Yeah, that's a nice trick. Okay. That's the graph. First you highlighted for the micrometer, right? Micrometer is the easiest of one of them. You do not need to worry about the command key or the control key, right? So because they're next to each other, you can plot it. Do for the micrometer. And then look what happens. When I click one of the data points, Look what happened here at the top. Do you see here?
Yeah.
Okay. So what he's doing? He's plotting the column Q and the column P, right?
Yes.
That. So what you wanna do? You wanna plot for the other two. You wanna plot the column Q and the column O, and then another one column Q and the column N. That's the only. It's a little bit awkward, but it's the only way that I can. I'll show to you how is that. You copy and paste the same graph, right?
Mm-hmm.
Highlight again, and then you change here to O. Okay, O and O. And now I should have the graph here for the vernier caliper. See that? See that? Mass
Yeah.
and point for the vernier caliper. Then you go ahead, copy this one. This one is going to work for you better. Paste, and then you repeat. Oh, even better. Now that you have the graph, what you have to do? You don't even have to, you don't even have to change the letters. What you can do, see that the columns here are highlighted, right? See that?
Yes.
All you have to do is to click and drag to get the ruler plotted.
Okay.
That's another way of doing that.
Okay. All right. Thank you, Professor.
You're welcome.
All right. Bye, Professor. Thank you.
Welcome. Serious. Interesting. Yep, I got it. Huh. Works.